I would like to present the concept behind the Forestcarbovision. So what we are going to do and why this project is important and what is the background of this project. So nowadays we all facing the climate change, and especially in northern and northern regions. And as you can see on this map, this is the area covered by called Northern Periphery and Arctic Program, including Finland, Sweden, Norway, Iceland and Ireland. And one of the biggest challenge for those regions nowadays is the climate change. And the climate change especially important for remote communities, because the remote communities in this region are highly vulnerable to climate change impacts. So everything is changing in the area due to the climate change. But also forests, not only communities, but also forests are expecting these impacts. And mostly because there is increasing stress. So for example, in Finland, we have a bark beetle. People were planting for generations spruce trees, and now this bark beetle is eating, for example, all those spruce trees, reducing quite a lot of potential for income for people who invested into it. Species composition is changing, and also the biodiversity is changing. So we are now living in a situation of permanent changing of the climate change, and this climate change is creating a huge impact of the people living in this area. If we will look to the way how we can combat, what are the approaches to combat the climate change. And according to most well-known studies from IPCC reports, so we need to reduce the greenhouse gas from atmosphere. And historically, greenhouse gas were reduced for some short period of times, but mainly due to big crises or big processes. So last time, this 7% reduction was due to the COVID. But anyway, the trend, long-term trend, is very strong. So it means if we want to change this trend on permanent basis, not just because of kind of some drastic or very important, very difficult events, but if we would like to change something, we need to reduce the CO2 content in atmosphere. So, and if we want, for example, to go to this Paris Agreement, we are talking about 50%. It's a huge amount, so it's a huge amount of carbon we need to remove from atmosphere. And of course, very important is how we are going to do it. And so worldwide, there is a need to reduce a lot of carbon from atmosphere. And at the same time, so when the forests are impacted by the climate change, forests could be used also as a tool. Forest could be, and growing trees could be used as a tool, as a way how we can remove the CO2 from atmosphere. And what are the solutions? And formally, how we can, materialize those solutions are based on the idea of using carbon credits. And so, principle is the following: that the companies nowadays, according to, for example, in EU, need to report. For example, if you are going to the bank, for example, nowadays in Finland. Before, if you go to bank and say, okay, I want to buy, for example, shares or stocks or invest into this and that company. Before, in year before, you will just be informed by the bank about the risks and about the potential profit and the impact. But nowadays, for example, banks also need to companies need to inform you about their climate impact. So you can already compare, like, what are your risks and what kind of impact you will have with the banks. So companies, in generally, more and more interested to buy those carbon credits because they need to show that they are doing something with their carbon footprint. So nowadays, majority of the companies in EU, they are just in the beginning, they are just calculating this carbon footprint. But in long run, they would need to show that they are able to reduce this carbon footprint. So this voluntary carbon credits is a really great idea to combat climate change, but recent publications, for example, by Guardian, show that 90% of the credits nowadays are invalid. So it's just a fake. So when we are talking about $900 million value asset, which is just created from very rough estimates, and nobody visited forest or checked the real presence, and so those is not happening. And the key problems why those credits are invalid. And the key problems are lack of transparency. So you cannot go and verify. So for example, you organize a project in some third country, somewhere in Vietnam or in Brazil, and nobody's going and checking there, and there are so many uncertainties. There are measurement inaccuracies. Many projects which were certified recently were relying, frankly speaking, on Landsat data. So in what is Landsat data is 30 by 30 meter pixel. You will never see individual tree in this pixel. You can see only if it's forest or non-forest, no more. Limited accessibility. So this was a kind of market only for big guys. So it means you cannot enable, for example, small forest owners to join to the programs, or it was very difficult to provide an access. And of course, the biggest risk is the double counting. So what was happening very often, and what was Guardian showing, is that practically, because we needed huge amount of credits, how to make it possible, you just count them twice. So for example, you count the credits which were sold by the government, or government reported those credits. For example, one country reported that their forest accumulated X and Y tons of CO2. And then at the same time, those X and Y tons of CO2 were sold also on voluntary market. So the same kind of good which was sold twice. And then what is really motivation behind of our project is so-called tropical offset dominance. So because currently the whole thing was relying on tropical forests which are facing those challenges with verification and governmental changes. So what we were thinking when we were developing this project, can we change the situation? Can we do the things differently? For example, to use Nordic forests in northern periphery and Arctic area, which could start offering transparent and verifiable alternative. So why do we need to send money, frankly speaking, somewhere far away where we cannot verify? But instead we can do something here on the ground, close to the customers, close to the forest owners, and verify it maybe in a little bit better way. What are the opportunities at the moment do we see how we are going to address this problem? And the opportunities are, first, what we can do, we can start empowering local remote communities. So we need to educate local people how to work with the carbon credits. We need to somehow advertise and to show the opportunity. And this opportunity is now really arising on EU level. We need to create solutions which will be kind of integrating long-term storage. For example, in wood construction, so when, for example, tree was growing for 100 years, and then you create, for example, saw logs, and then from saw logs you, for example, put this wood into the building. And hopefully today we will be very proudly showing you our institute building today afternoon, where there's some parts of the wood we are coming, I don't know, maybe colleagues will correct me, maybe originated 500 years ago or 300 years ago. And it's serving the purpose. And then what we are going to do, or what we see an opportunity, is to bring digital innovation to forestry. When we are talking about digital innovation, nowadays it's hype, everything is AI, about AI, but how we can utilize AI to maximize the carbon, for example, accumulation function of the trees. How we can use the novel instruments like drones, terrestrial laser scanners, some alternative new instruments to impact the decisions on the ground. And this is about digital innovation in forestry. And of course, the last thing, I think, which is really, we have a lot of hopes and a lot of expectations is EU momentum. Inside European Union, there is last year in 2024, it was this law approved about carbon farming, so I could call carbon farming law. And now it is a process when the whole thing is developing. And practically, I would say my last month I spent almost on weekly meetings in Brussels, in remote discussions about designing the methodology, about building this new market, about understanding what are the mechanisms. So we are expecting that EU already next year will become a very big driver, so that the thing what we are developing in the project could be quite quickly turned into money, and it means resources for local communities. So I would try to open a little bit. So what we have at the moment, we have actually game changer, because first of all, we are in our institute, we're working on different instruments, because nowadays we don't need, for example, satellites, but we have ability to measure reality without sampling and extrapolation. So, and I'm talking mostly about laser scanning, and these novel laser scanners, those are, in the past, when I've seen my first laser scanner, it was, I think the weight of the first laser scanner was almost 300 kilograms, which you can put into airplane, and you need to have a really big or powerful airplane to carry out the whole thing. Now, the weight of the laser scanner, maybe I'm mistaken, maybe Mauricio can correct me, is it like 100 grams or more? So we are talking about grams. And it's really, the technology really made a big shift, and in terms of weight and in terms of also on the cost. So I think we bought first laser scanner to Luke for something like 50,000 euro or something like this, maybe several years ago. And now you can buy it on less than maybe 5,000. So the whole technology is developing, but what is giving to us, because when we use a laser scanner, we can mount it on any different platform. We can put it on a person, we can put it on a drone, we can put it on a harvester or machine going to the forest, or on a car. So the way how we can where we could place those laser scanners could be every different. But what this laser scanning is giving to us, it's enabling us to create a digital twin of our forests. So by knowing, for example, the size of the trees at first period of time, and knowing the size of the trees at the second period of time, we could calculate the difference. And this difference can be calculated with novel laser scanners, not only on the level of diameter or height increment, but novel laser scanners enable us even to count every needle and say, like, how many needles on this tree were on year 2025 and how many needles were on the tree on year 2026. It sounds really unbelievable, but this is possible. We are already in our institute working with such kind of technology, and we have this data, and this is really reality nowadays. The second, so when we have this laser scanning data, so what we can do, we can actually turn this forest into digital copy of this forest, so-called digital twin, based on laser scanning data. And we have this digital twin. We can, of course, if we create two digital twins for two different periods of time, we can do change detection. So to understand, okay, where was the highest diameter increment? Where was the highest height increment? But the second thing, of course, we could do better decisions. So what we can do with the forest in order to maximize, for example, growth without adding additional, maybe fertilization or something. How we can optimize the tree selection, where we could detect, for example, biodiversity, where we could create some novel thoughts, or kind of. And I think if at the moment we do not understand for 100% the potential, because if we combine those digital twins with AI, I'm sure we could try to, we probably will be exploring or discovering soon some very innovative thoughts that we even never thought before, how we can utilize this data. But because the data is digital, so it's opening for us quite a new, interesting opportunity to maximize. So, and this data enable us to turn information into the management decisions. And if we have a management decision, it means we could create value from those management decisions. For example, how it may look like. So imagine if you have a forest property. So you can, for example, create a digital twin of your forest property. I'm just showing here the aerial image for the way to simplify the thing. So if you have a, for example, digital twin in April, when it was still snow and trees were still frozen and no growth. And then you create a second digital twin, for example, in September. So when the trees already stopped their growing season, so what you can do by this change detection analysis at the level of the digital twins, first of all, you can make this tree-wise inventory. So it means every tree will be on your map and every tree will be measured. But the most interesting thing, you can calculate how much was the height increment, how much was the diameter increment at the level of single trees. And of course, it's easy then to, it's just a mathematical thing. So if you know what kind of tree species it was, and if you know what kind of, for example, wood density, where you can convert this information into carbon. But if you link, imagine if you link to this information tree ring data, for example, you can also not only forecast the future, but you can also drive this model back and see what was the forest dynamic in the past, how the trees were influenced by competition in the past, what was the impact of climate change on the forest growth. So it's opening quite a lot of interesting opportunities, because you don't take only one sample, but you have quite a community. So we are not talking about single tree, but we are also talking about community of trees. And when you have those digital twins and you made a change detection, so you could calculate how much carbon tree actually taken from atmosphere. And then the way what we see nowadays is we can record this information. But to enable the transparency and accessibility, we can bring this information into the blockchain platform. Because one of the critics in this Guardian paper were saying that practically, since the baseline was very weakly identified, so it means you can, there were a number of opportunities also to manipulate the data. So the blockchain enable us to store information in a way that if somebody will start doing modifications, it will be immediately visible. So it could be used as a kind of safeguard to guarantee that the data what we are creating and publishing is really staying in the format where it was. So this is just illustration. This is at the level of single tree. So if we take one scan from one single tree, we can already see quite a lot of details, and we can, for example, with conifers even calculate the height increment in the past. So because the conifers are growing with those annual shoots, annual whorls, so it means you can calculate what was the growth, height growth. And if you combine this data, for example, you can combine it with the tree rings data. So you can combine the height increment with diameter increment, and as a result, you will get the total increment of the trees. And this is kind of what we see as one innovation in this direction. Then, if I jump to the EU, so what's going on in EU market? So of course there are a lot of discussion about carbon farming, and there are certain kind of open positions which is EU trying to solve. I already mentioned today about this requirement for big corporations to report their carbon footprint, and next year they will need to report not only their carbon footprint, but what they're starting to do to reduce this carbon footprint. But there is also quite a big pressure going on, especially for big food processors and biomass processors. And I took this slide from EU Commission because they most likely will create the first demand within the value chain. But then there is quite a big question nowadays, because besides the demand, you need also supply. So who is going to supply those carbon credits? And the supply will be most, if we talk about forests, will go from farmers and foresters. And we are talking mostly about voluntary participation. So when it comes to the financing on a kind of on EU level, there is what has already happened. There is a so-called Corporate Sustainability Reporting Directive. It's already approved, it's already working, it's already applied. Companies already reporting. At this particular moment, European Commission is finalizing a document about the green claims to remove the greenwashing. So it means nowadays you can make whatever green claim. you could say nowadays that okay, carbon neutral food or carbon neutral hotel or something like this. But the EU Commission is now setting very clear requirements how you could make this green claim. And I think in coming weeks this final document will be published, and it means it's creating also basis. But what is also important is there are a lot of studies on market-based approaches and also in forestry value chain. So we are expecting that already in future we will have this system operational. And this is a timeline. So what was happening last year when we were writing the project proposal? EU Commission already made this regulation, so they made this, it was entering into force this carbon removal and carbon farming directive, which is already defining the legal basis. Now, at the moment, this particular moment, there are discussions on certification schemes, like how we register this carbon, how we verify it by the third party. And I think our project really exactly fit into this process. And then next year, there will be recognition of those schemes and possibly issuance of the first carbon credits. So I'm just putting in the context of our project. Within our project, we are going to create a demonstration site. In best case scenario, what we can do, maybe we will have already our first credits next year. Depends on the sites, how well we will be working in the project, but this is kind of like would be really complicated mission, but very challenging task, but this is reality and possibility for us. But even though, if we will not have in 2026, if we will have it later, it's no problem, because in 2028, European Commission now discussing about starting registry of a carbon. So it means, if, for example, I as a forest owner created a carbon accumulation project in my forest, and for example, in year 2025, and for example, in year 2026, I already was able to show that, okay, my forest were growing and sucked certain amount of carbon from atmosphere. By 2028, I will be able to bring it to EU registry. And this EU registry will also act as quite a big marketplace. Practically, it's not only about registering carbon, but also creating a situation where you can buy it for those companies. If we think about Finnish context, because one of the important issue is about additionality. I know that it will be talked a lot today, later, but when we are talking about carbon farming, we cannot take all the carbon. So of course the trees are growing, and we cannot claim that all carbon what we farmed. What we could claim is the carbon which is appeared because of additionality within our project. So it means there is a business as usual. So the trees were growing as they were growing in the past. This carbon we cannot sell. But then if we do something else, or if we do something extra, we fulfill this additionality criteria. So it means we create something different in our project. So the trees started to grow faster. And it means this additionality, this amount of carbon which appeared due to the faster growth of the trees, we can bring to the market. And in Finland, for example, in Finnish case, it could be if we plant trees on abundant forest land. In Finland, we had a great program 1 year ago, which is called Metsitustuke, which was enabled people who owned abundant land or land which was not covered by forest to simply plant the trees, and the state were providing quite a huge, I would say, subsidy to forest owners. Then what we can do, we can start doing things with forest management and agroforestry, maybe for Nordic conditions. For some countries, for Ireland, maybe it would be important, but for Finland, maybe it's less important since agroforestry is not yet in a wider scale here. We could increase planting density and scenic density. We could change management regime. For example, we could increase planting density and then do more earlier youngster thinning than according to business as usual. We could think about biochar. There are a lot of discussion, a lot of hype about biochar, but the problem with biochar is that the costs of converting this biomass into biochar are still very high. So you still need energy, you still need a lot of resources to collect this low quality wood, to turn it to biochar. Because if you bring the biochar later to the forest back into the soil, it can stay in the soil for 1,000 years. But to collect it and turn it, it requires a lot of changes. There could be operations about managing young stands. For example, what we could do, we could optimize the mixture of the species. Maybe to change the approach, like traditional in Finland, we have approach, if you planted spruce, then you need to do young stand management in a way that you remove practically all other tree species and provide opportunity for spruce to grow. But what if we do something different? what if with precision forestry we select which trees to move or not? Kind of would it enable us to achieve the additionality? And then we are talking about this certain smart thinning operations and some species mix and optimization techniques to increase the growth and to increase carbon accumulation. And fertilization, which is very common in Finland nowadays. So there are a number of projects when you, for example, people bringing ash back to the forest and fertilizing especially drained peatlands in order to increase the forest growth. But what I see as the biggest opportunity for large-scale implementation in Finland is continuous cover forestry. And continuous cover forestry is a type of, if you never face this approach, this is type of forestry when you never have a clear cut. It's kind of you putting your forest in such a management regime of permanent thinning. And today, I'm very proud we will be showing you some examples in afternoon. So you will see how it's done in practice and what is continuous cover forestry in reality. But there are a number of advantages because you do not disturb the soil, and it means you store carbon in the soil. You are avoiding the cost related to soil preparation. You avoid the cost related to the regeneration. You don't need to plant the trees because you rely on natural regeneration. So there are a number of advantages. And then, of course, maybe last opportunity is extension of rotation cycle. So kind of if it allows you, at the moment, because the market is not yet developed, so the carbon market is just starting. So that's why the carbon price is not yet so high that it's really having significant impact. But what if the carbon price will jump? So then if the price will increase, we will, I think, see very clearly those actions. And then last thing, which is rewetting of the peatlands. So what is the project vision? So within this project, we would like to build climate resilient communities. So what we would like to do, we would like to create a demonstration sites in eastern Finland, in northern Finland, close to Oulu. Then we will have a demonstration site in Iceland, and we will have a demonstration site in Ireland. And for each of the demonstration sites, what we are going to do is to also find local communities, local forest owners, local people interested about it. The interest can be different. They could be owners of the area. They could be interested in participating in the area, in planting the trees and doing activities. For example, they could do something it, or they could be, for example, buyers of the credits. And we will discuss later how to implement in practice. Then what we would like to do, we would like also to bring innovation to those sites. So there is a tradition of how the things should be done. And we don't want to disturb this tradition, but we would like to complement how the traditional approaches could be complemented with the new technologies. For example, can you do something different? Can you, instead of going days and nights in rubber boots and seeding the trees, can you just send a drone and seed the same area in half an hour? Or can you, instead of measuring the trees days and nights with traditional instruments, can a laser scanner do it faster and more efficient and more accurate? So we'd like to bring some innovation. And then what we would like to do, we would like to create a transnational impact so that the experience what we will learn within the project, we can expand further and we could communicate it for the whole all other Nordic countries. And we would like to publish our experience, what we learned from our project, so that if somebody would like to repeat it maybe in Sweden or in Norway, this information will be available. So that's why the reports, what we will be producing within the project, the materials what we will be producing, will be publicly available. So what are the objectives of our project? The first objective, we want to boost the carbon sequestration on demonstration sites. So it's not about selecting the forest site. But once the forest site is selected and when once we created a digital twin or digital copy of the forest site, we will try to analyze the local context, how we can boost the carbon sequestration. Is it about fertilization? Is it about certain intervention, maybe smart tree selection or certain other things we need to identify? Maybe in each site it will be different story. Then we could develop accurate carbon accounting tools, mainly based on LiDAR, based on drones, AI, novel algorithms. And we would like then to pilot and validate the solutions on the ground. So that's why we will, for each site, we will create 2 digital twins. One before, when we start the project, and after 1 year or after 2 years, we could create a second or maybe third even digital twin to show, is it really working? Like, do we kind of, what is the accuracy? What is the source of error? What is the magnitude of error? And we will want to do it not only for our curiosity, but we would like to engage a stakeholder and do some capacity building events. So for example, if we will do the test site in Finland, we will create this test site, but then at the end of the project, together with our partner Metsäkeskus Finnish Forestry Center, we are going to organize a seminar for forest owners. And we're going to take forest owners to explain them the concept, bring them to the forest and to show, okay, how it's working. What is the reality? How the drone operates, how you measure the carbon, how the calculation goes. So somehow open to them an opportunity. And of course, inform them about opportunities which are existing, I hope will be existing in stronger format within EU. And then last activity, what we are going to do, we are going to create within the project a policy brief. So we are going to summarize our experience on those demonstration sites, on those areas, and reflect it into the policy brief and make it publicly available. So who are the partners? And I'm very proud that today we have all the partners with us. Our institute, Natural Resource Institute Finland, Luke, will coordinate the project. Then we have an expert in community engagement and with a lot of background from all kinds of climate and carbon-related actions from Ireland. And I hope they could share with us some methodologies, how they do the things with their experience. We have also Agriculture University of Iceland, represented by Olafur, and he's also presenting our associated partner Land and Forest Iceland. And there are also a lot of things. I think Iceland, from my point of view, is a forerunner. They already did a lot of things, what we are now just discussing. It's already existing for a certain period of time in Iceland. So we could learn actually a lot of how to do the things. And then we have also all University of Applied Sciences with drone technology. And I hope that we could somehow, and they have also experience in operations, not only in Finland, but outside. So what we would like to test, like how we do the things, for example, if the experts from all University of Applied Sciences go to Iceland or Ireland, get all needed permissions, fly the drones, create digital twins on the ground, and then this is also learning curve for us, how we could make this process transnational. And then we have associated partners as University of Eastern Finland here in Joensuu, Forestry Center, Land and Forest Iceland, and we have one business partner, which is Brim. It's a very big company in Iceland, which is already investing. They are already buying lands, doing afforestation in order to produce carbon neutral fish. So, which is very nice link, and I think we can also learn a lot on working with those stakeholders. So the project is planned for 3 years, and our budget about 900,000 euros, so close to million, and 65% it goes from Interreg Northern Periphery and Arctic program, and then we have also this 35% so-called matching funding. And for Finnish partners, I would like to say that quite a big part of this matching funding is coming from Lapinliitta, Regional Council of Lapland. So it's not only organizations input, but also country input. And this is a project budget. As you can see, the majority of the cost goes to the staff. So we would like to really fund work of the people on the ground and producing the meaningful results. What is the timeline? So how do we see the implementation of the project? So we are now launching the project, and we will start with creating those living labs. We will establish demonstration sites. We fly those drones first time on those demonstration sites to create a baseline. So to create a first copy from where we will start counting the changes. We will calculate initial carbon amounts at the level of individual trees on every demonstration site. Then next year, we start implementing pilot actions. So we will start doing some interventions. And we create a second digital twin. So it means we will be able already after the second year to calculate change detection. What was the growth of individual trees? So how much carbon was accumulated? And then on the third year, we would like to concentrate on local capacity building. So from the material what we will collect in the first and the second year, we will produce reports and demonstrations, some presentations, and we will get some experience. And we would like to share this experience with the local stakeholders to inform them about opportunities, to inform them about ways how, for example, they could integrate it. And within this process, we are going to develop so-called forest carbon farming toolkit, which will be publicly available. And it will summarize all the knowledge what we gain about different aspects of carbon farming in Nordic countries. And then on last year, we are mostly concentrate on finalization and dissemination. So what we are expecting at the end of the project, and what are the kind of our KPIs? So our KPIs at the moment that we need to have 8 organizations cooperating across borders. And I think by presence of here of the key people, we already fulfilled this KPI. So we already started this cooperation nicely. So we are going to develop this so-called forest carbon farming toolkit. And we are going to test this toolkit on demonstration sites. And based on the experience, we are going to draw the policy recommendations. And those policy recommendations will be in the form of policy brief. For example, in our institute, we have quite a good experience of releasing those policy briefs. So I think we could do it jointly and create this nice joint policy brief. That's all maybe about vision, mission, and introduction.